Hi, welcome to my video on the graph of a geometric sequence. The graph of a geometric sequence. So the equation I've written here is Tn equals 2 to the n minus 1. So we know that, or should know, that n belongs to the integers. So the integers, n belongs to n, which is the natural numbers. Integers are I. So we can only have the natural numbers here. So that's n, and that's the Tn. The natural numbers are 1 and 2 and 3 and 4, etc. Notice we're not starting with 0. We're starting with 1, the natural numbers. So if we take a 1 and sub in here, 1 minus 1 is 0. 2 to the 0 is 1. If you sub 2 in for n, 2 minus 1 is 1. 2 to the 1 is 2. You sub 3 in for n. 3 minus 1 is 2. 2 squared is 4. And you sub 4 in. 4 minus 1 is 3. 2 cubed is 8. Notice the first term, even though I'll write it down again. That's a 1 times 2 to the n minus 1. So notice there's a 1 understood to be in front. So the first term is a 1. And notice that 2 is the ratio. So you're going 2 times 1 is 2. 2 times 2 is 4. So the ratio is 2. So you're doubling it each time. So when n is 1, t is 1. When n is 2, tn is 2. n is 2, tn is 2. When n is 3, tn is 4. When n is 3, tn is 4. That's up right here. And so when n is 4, which is right here, tn is 8. And that's a 5, 6, 7, 8. So that's up right here. And notice because n is an integer, n, again I said integer, n belongs to the natural numbers. I can only put dots. I can't join these up because there's a 1 and a 2. There's no numbers between 1 and 2. There's only a 1, 2, 3, and 4. So these are the points that are on this graph. Now this keeps on going because I can put a 5 in and double it and I get 16. I can put a 6 in and double it and get 32. But that just goes on up and up and up with dots. So your domain here is n belongs to the natural numbers. And your range, because this goes on and on and on, the only way you can do your range is the set of all Tn such that, or Tn is equal to 2 to the n minus 1, where n belongs to the natural numbers. So the only way that I can name all these points, or values of Tn, is to write the equation. So once you put 1 in, then you get, the first one is 1. Once you put 2 in, you get a 2. So this equation is representing all these values here that keep on going, and these keep on going. There's no way you can say it's greater than 2 or less than 3 or anything like that. Now, does the graph have any intercepts? In other words, does the graph intercept the real axis where n is? And the answer is no. And does these points intersect the Tn axis? No. So there's no intercepts. It doesn't intersect this axis, which is n, and doesn't intersect this axis. So there's no intercepts. Are the points discrete or continuous? So notice these are dots, and discrete is dots. So the points are discrete, they're dots. Continuous would be, if it was continuous, the graph would be solid, shaded. So discrete, data is discrete, dots. Let's go over another idea. What about if we graph, look at this, and we say we got 16, 8, 4. That's a sequence going on and on and on. So if we graph this, notice that we have, this is a 1, a 2, a 3, 4, 5, 6. So this is term 1, term 2, term 3, term 4, term 5, term 6, and this is a sequence. But notice it's going down. So when you got a 1, you have a 16. So there's 1. So you got to go, there's 15. So there's 16 right here. And when you have T2 or N is 2, you have an 8. 2 gives you an 8. So there's 10. So 2 is 2, 4, 6, 8. And again, I'm just eyeballing it. And I got 3 gives me a 4. So 3 gives me a 4 right here. And a 2. Sorry, when N is 4, I have a 2. 4 gives me a 2. When N is 5, I have a 1. N is 5, I have a 1. And when N is 6, I have a half. 6 gives me a half. And notice now that it's coming down this way. It's coming down this way. So that means if you were to do number 7, number 7 is here, it would get closer. If we do 8, it's getting closer. This goes on and on and on, but it'll never touch. It'll never cut this axis, N axis. And no matter how far we go, we can't go any further this way. So it has no intercepts. And the equation, well, get the equation, it's Tn is T1 r to the n minus 1. So the first term, T1 is 16, so that's a 16 there. And the ratio, notice the ratio is 8 over 16, 1/2. And 4 over 8 is 1/2. 2 over 4 is a half. Notice you're going to half of 16 is 8, half of 8 is 4, half of 4 is 2, half of 2 is 1, etc. So the ratio is a half. So this is the equation that represents a sequence. And notice it's dots. Again, it's not continuous. So the domain is n belongs to the natural numbers. And the range is the equation. So the range is a set of all Tn such that Tn equals 16 to the 1/2 n minus 1, where n belongs to the naturals. And again, we have to name the equation in order to represent all these values here, because there's only dots. So are the points discrete or continuous? And again, it's discrete because we have a series of dots. Continuous would be when it's shaded in solid. In other words, continuous is including all the points that's on this number line. All the points are represented. So if I did a shading like that coming down like that, I would have continuous because it's representing all the values of n, which is real. So that's just explaining the graph. As we do more of these videos, I take my time and explain one idea at a time. If you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.